Welcome. Today I will be giving a short presentation on James Lovelock's Gaia Hypothesis. Let's get into this. Gaia Hypothesis proposes that our planet functions as a single organism that maintains conditions necessary for its survival. Formulated by James Lovelock in the mid-1960s and published in a book in 1979, this controversial idea has spawned several interesting ideas and many new areas of research. While this hypothesis is by no means substantiated, it provides many useful lessons about the interaction of physical, chemical, geological, and biological processes of the Earth. One of the most popular examples of the Gaia hypothesis is the hypothetical world of Daisy World. Daisy World is seeded with two varieties of daisies, and they are its only life forms, black daisies and white daisies. White-petaled daisies reflect light, while black-petaled daisies absorb light. Because the black daisies are there, the atmosphere starts to heat up, because they absorb more energy than the white daisies, and the white daisies start to die. After enough time, it gets too hot, and the black daisies start to die. And when the black daisies die, the white daisies are able to come back as the planet cools down. The white daisies continue to cool the planet down until it gets too cool. Then, after the white daisies die, the cycle starts to restart, and the black daisies start to take over again. This supports the Gaia hypothesis and the idea that Daisy World's biosphere acts to maintain a homeostasis of the planet's physical conditions. For example, in this case, atmospheric composition and temperature. And here's how it looks on a graph. This includes negative and positive correlation. Now, James Lovelock applied this idea to the complex Earth as well. Now, the Gaia hypothesis also says that Earth's biosphere acts as a homeostasis of the planet's physical conditions. Here's an example. As the Earth warms, more evaporation and more precipitation occur, and then more CO2 is dissolved into the rainwater, and then less CO2 in air means that there's less of a greenhouse effect, which then cools down the Earth. And then as there's less evaporation and less precipitation, less CO2 is dissolved in rainwater, and then more CO2 in air means more greenhouse effect, and so then the Earth starts warming again and the cycle restarts. This is how the Earth regulates its temperature. Now, the Gaia hypothesis goes farther than that. It includes all cycles of the Earth, including the carbon cycle, nitrogen cycle, and the water cycle. According to Lovelock, these cycles and many more work together to make the Earth work like a living system, even though it's not alive. Today, the Gaia hypothesis continues to be an extremely controversial subject, and is skeptically received by a large part of the scientific community. Nevertheless, the idea that the Earth acts as one organism is undoubtedly very interesting and causes one to think about the Earth as a whole and as one organism. What do you think? Thank you so much for watching this presentation. I hope you enjoyed. Here are my cited sources.